So today I would like to work on some exponential properties, and this is from lesson 1.4 to give you all some practice and support in that area. And so I'm just going to go back to some basic rules with exponents. I'm in my office, and so that's why you can't see my face at all, because I don't know how to get it to show up. So our basic rule of exponents is really a symbolic way to show a shortcut. So 3 squared, and we read this as 3 squared, or we might say 3 to the second power. You might see it read either way. This really means that we have 3 times 3 2 times. And there's always an unsaid times 1 there, but you just don't see it because anything times 1 is the number. So 3 squared is 9. Okay, so let me just add another one. So let's say I had 4 times 4 times 4 times 4 times 4 times 4. That's a lot of 4s being multiplied together. So the value of using an exponent is that I can write this with a symbolic way. 4 is my base. And then the number of times that 4 was being multiplied together is 1, 2, 3, 4, 5, 6. And so 4 to the 6 is a much more simple way to write the same thing as 4 times 4 times 4 times 4 times 4 times 4. Okay. The next one I wanted to look at is -3 to the second power. So the negative is not included in the square. So you can see down here, it has -3 in parentheses squared. The -3 is included in the square. So this is saying we're taking the -3 times 3, which is a -9. Then we have down below, we have a -3 is in parentheses squared. And so that's a -3 times a -3, which is a +9. Okay. So let's look at the next one. When we're multiplying x's together, you can see that x to the third times x to the fourth is the same as x times x times x. There's the 3 of them from this first one, and then times x times x times x, and there's 4 of them from the second one. That means they're all of the same base. So we can really put them symbolically together by taking 3 plus 4, which gives us x to the 7th. Okay, now we have something called exponents to a power. So this is 2 to the third to the power of 2. So what this 2 really means is I have 2 of these 2 to the third. And then we all know that 2 to the third is really 2 times 2 times 2. And then the second one is 2 times 2 times 2. So we have all of the same number being multiplied. So again, we can use our exponent to represent that in a more simple way, because there's 6 2's being multiplied together. So you can see that you could visualize this 2 to the third squared as 2 to the third times 2 to the third. So we're adding our exponents of 3 plus 3 to get to 6. If you have an exponent to a power, you can multiply. So let's just write that. An exponent to a power, we can multiply them. Okay, in my other exponent video, I talked a little bit about negative exponents. So negative exponents are really just a positive exponent, but it needs to be in. So if we treat this as 4 to the negative 2 in the numerator over 1, which we don't see when it's a whole number, there's no need to put it over 1, but it is technically a fraction over 1. For it to be positive, we're actually going to say 1 over 4 to the positive 2. So the negative 2 just says that it really should be in the denominator. Okay, so that becomes 1 over 4 times 4, which is 1 over 16. Okay. And then we could also have, what if we had 1 over 4 to the negative 2? That really means that it's actually going to be a positive 2 exponent if it were in the numerator. Okay. So the next one is a fraction, 3/5 to the negative 2. And so that means we're going to do 1 over 3/5 to the positive 2. And so that's really 1 over 3/5 times 3/5, which is 1 over 9/25, which is really the reciprocal. So it becomes 25/9. So the negative exponent just means that if it's in the numerator, it goes in the denominator and becomes positive exponent. If it starts in the denominator and it's negative, you move it to the numerator and the exponent becomes positive. So don't forget that all of the odds in your book have answers in the back of the book. So you could always go to an odd problem that's similar to what you're working on to be able to check your answer. Okay. Let's jazz it up. Let's do one that's a little bit trickier here. So we're multiplying 4x to the 6, y to the 6 times 3x. So the numerical values, 4 times 3, get multiplied. And then we're going to group our x bases, x to the 6 and x, and then our y's. So this becomes 12. And that's x to the 7th, y to the 6th. So let's do another one. We have 20, we have 8a cubed, let's rewrite that, 8a cubed b cubed times 5a squared b. So I'm going to group my 8 times 5, my a cubed, my a squared, and then my b cubed and my b. So we have 40 a to the 5th, b to the 4th. So let's look at somewhere we're dividing, where we have fractions where we're dividing. So we have 20x to the 7th over 5x to the 4th. So our division rule says we're going to take 20 divided by 5, and then we're going to take x to the 7th over x to the 4th. So this becomes 4. And then x to the 7th, if you think about what it really means, 1, 2, 3, 4, 5, 6, 7, 7 x's, and then 1, 2, 3, 4 x's on bottom in the denominator, then we can cancel out the common x. So there's 1, 2, 3, 4, and we're left over with x to the 3rd on top. Now you can also see that that means if you take the numerator exponent, the top exponent, and subtract the bottom exponent, you would also get x to the 3rd. that is what you will do once you become more confident with what it really means in the background. So let's do another one. Okay. So we have 4 divided by a -2 is a -2. And then we have more x's on top than bottom. So 4 minus 2 is x squared. And then we have 3 y's on top and 1 on bottom. So we have a difference of 2 y's. So let's do some with more with our negative exponents. So if we have x to the -3 over x to the 5th, I choose, instead of just using the rule, I choose to move so I have all positive exponents. So I'm going to have a 1 on top, and then I have the x to the 5th on bottom is going to stay because it's a positive exponent. It's happy right where it's at. The only one that we have to move is this -3, and that's going to go to the bottom. And so now I have all x's in the denominator, and I can combine them as 1 over x to the 8th. Okay, so the next one, my a to the 7th is happy right where he is, and the a to the -2 is going to go to the top, so it can be a +2. And then I'm just going to combine because I have like bases, so I have 7 plus 2, so I have a to the 9th. Now, what if I had t to the -4 over t to the -3? Again, I would move them to make them both positive. So I'll have t to the +3 on top, t to the +4 on bottom. And it looks like I have more t's on bottom. So I will end up with 1 over t in the denominator, because my 3 t's on top will cancel out with 3 of the t's on bottom. Okay, so let's say we have x to the 5th over x squared to the 3rd. So we're going back with our rule that we said that an exponent to a power, we can multiply them. So we have an exponent to a power. So I always go through and distribute my power from the outside to the inside to everything on the inside. So it's going to get distributed to the numerator and the denominator. So this is going to become x to the 5 to the 3rd over x squared to the 3rd. And this is an exponent to a power, so we're going to multiply. So this x to the 15 over x to the 6th. And then I have more x's on top, and so I'm going to take the difference, and I'm going to end up with x to the 15 minus 6, so we have x to the 9 as our answer. Okay, let's do some tricky ones here with negative exponents. So let's say we have x to the -4 cubed, x cubed to the -4, all over x to the 10. So I always take care of my exponent to the power first before I move things with my negative exponent. So this is going to become x to the -12 times x to the -12 over x to the 10. And then because both of these are negative exponents, I'm going to move them to the denominator. So I'll just have a 1 on top. So I have x to the 10 x to the 12, x to the 12. They're all x as a base. And so I'm going to have 1 over x, and then I'm going to add 10 plus 12 is 34. Okay, let's do another one. 5a to the 8 b cubed over 20 a to the 5th b to the negative 4. So my 5 over 20 reduces to 1 over 4. And I have more a's on top than I do on bottom. So I have a to the 8 minus 5, which is a third to the 3. And then my b to the 3 will stay where it's at, but the b to the negative 4 needs to go to the numerator to be positive. So I have my 4 left in the denominator, and then I have a cubed b to the 7th. And you could put a 1 out in front if you wanted to, but it's not necessary. Okay, let's jazz it up just a little bit. So let's say we have x to the negative 7, y to the negative 2, over x to the negative 5, y to the 6, to the negative 1. So because we have exponents to a power, we're going to make sure that we distribute this negative 1 to all of the pieces on the inside first. So this will become x to the positive 7, y to the positive 2, over x to the positive 5, and y to the negative 6. And so the only thing I need to move is this y to the negative 6. So I have x to the 7, y squared, y to the 6 over x to the 5. So I have more x's on top than I do on bottom by 2. So it becomes x squared, and then y squared times y to the 6. I can combine those, and we have y to the 8. And let's not forget that if we have a squared times b to the 3rd over 2, a to the 5th, b to the 7th, all raised to the 0 power, we don't have to combine anything because this 0 power means we have 0 of this fraction being multiplied, but there's always an unsaid 1. So that's why anything to the 0 power is 1. Catch me back for another video or reach out if you have other questions.